Hello everyone. Welcome to our channel 361 Physics. And as you know that we have been doing here the solution for subject equation of class 11 examination related with physics. So in previous video we have already done the discussion of group B up to these 4 number questions. Okay. Mm, So not 4 number, sorry, up to 3 number question. So now in this video let us begin from the 4 number, and in this particular question if you read this you will find here it is related with the kinetic theory of gases. So let us begin the solution. Okay, so in 4a we have given here that what is the difference between the ideal and real gases. Explain how can we convert real gas into ideal gas. Okay, so as we know that, okay, real gas and ideal gas. Okay, so as we know that real gas and ideal gas, there are two in reality we observe this type of gas, real gas, but this is ideal gas is a concept. Okay, so real gas and ideal gas have one main difference. That difference is related with the intermolecular force of attraction. Okay, so in this particular gas, that means real gas, there is intermolecular force of attraction. Intermolecular force of attraction. attraction but in the case of ideal gas, this part is absent. Okay, that means ideal gas do not have intermolecular force of attraction. So that's why we can say that real gas can be condensed. Okay, condensed, but ideal gas cannot be condensed. Okay, so I think this is enough for this question, and the question weightage is too much. That's why we can write here real gas has intermolecular force of attraction. Ideal gas, there is no intermolecular force of attraction. Real gas can be condensed, ideal gas cannot be condensed. If you want to add more points, so you can write here easily the total energy. Okay, total energy of real gas is composed of two type of energy. One is potential energy, and this energy is due to the function of intermolecular force of attraction. Intermolecular force of attraction, and it also contains the kinetic energy, and this is due to the temperature or randomness of the molecule. But in the case of ideal gas, the intermolecular force of attraction is absent, which implies that there is no potential energy. Okay, potential energy is absent. So the energy of ideal gas is purely composed of composed okay composed of uh, kinetic energy. Okay, so you can write these 2 or 3 points for this question 4a. Now let us move to the question number b, and in this question number b it is given that, let me drop this first. Okay, so that I can write here. Okay, now we are going to solve the question b, and in this question you can see here it is given that in a project work of a student has taken 1 liter of air, that means volume of air is provided, and temperature of that particular air is 20 degrees Celsius, and atmospheric or pressure of that air is 760 mm of Hg, is heated at constant pressure till its volume get doubled. Then he has taken its temperature and found as the 293 Kelvin. Discuss with proper calculation whether his project get accepted or not. Okay, so it is given initial and final condition. Let us write this. In initial condition, volume is 1 liters, and then after, sorry, pressure is given as pressure is given as 760 mm of Hg. You can convert it into uh, Newton per meter square by multiplying. This is height of the mercury, that's why you can convert it by multiplying with 10 raised to power minus 3. Okay, it will becomes meter, and then after, as you know that pressure is the product of SdZ, liquid pressure, that's why we have here height. Now we have to insert the density of the mercury, which is 13,600, and then let us take the gravity 9.8. So after solving this, we will get pressure here in Newton per meter square. Okay. Now another thing is given here, initial temperature, which is 20 degrees Celsius. If you add here 20 273, you'll get the temperature in Kelvin scale, and its value becomes 293 Kelvin. Yeah, 293 Kelvin. Yes. Okay. Now this is our initial condition. Now for the final condition, it is given that volume is double. That means initial volume is 1 liter. You can write here 2 liters. I have not convert this volume into meter cube. You can convert it if you like, because it will cancel out itself. That's why I have placed it as it is. If you want to convert, then you can use the relation that 1 meter cube is equal to 1000 liters. Okay, and that means if you want to convert this 1 liter into meter cube, you have to divide it by 1000. It will give you the value of volume in meter cube. Similarly, you can divide here 2 by 1000. So this is value of B2, and it is, I think, provided that yes, constant pressure, that means P2 is also similar as that of P1. So P1 and P2 is constant, and then temperature found out by the student is 293. Okay, so first we have to apply the relation between the pressure, sorry, not pressure, volume and temperature. So we know that V1 by V2 is equal to T1 by T2. We have this expression from the Charles law, which according to Charles law, volume of a given gas is directly proportional with its absolute temperature at constant pressure. Okay, so we are using it. If you add all of these value, you will get the value of T2. But logically, we can say that as volume is directly proportional to T temperature, which means that as volume is made 2 times, okay, volume is increased by 2 times, which means the temperature must increase by at least near about 2 times. But the student has found here the temperature is 293, which is exactly equal with the initial temperature. So logically, we can say that the project work submitted by the student is going to be rejected. But if it is given that we have to show the calculation, proper calculation, and finally we have to conclude that result. So you have to write all of this calculation in proper form, and then at the end you have to conclude your answer that by saying that the temperature we have found, or the temperature must be this value, and he have found that, sorry, he has found that 293, which is logically is incorrect, as well as by calculation we have found this value might be that 1300 something or more. Okay, so the project work submitted by him must be uh, rejected. Okay, now let us move to another question. First, let me rub this part so that I can easily write here. Okay. Okay, so okay, that's fine. Okay, Now we are moving to the question number 5, and in this question, let us see. Okay, this is related with mirror. So it is given that is there any condition for which concave mirror can form virtual image? Okay, if any, describe it with necessary diagram. So as we know that this is our concave mirror. Okay, oh, sorry. Okay, this is principal axis, this is focus, yeah, and this is pole. If we place any object in between focus and pole, then in that particular case the image will form where, in the same side. Okay, in the same side of the object, and the nature of this image will be virtual. Okay, you have to just complete the ray diagram, okay, by joining this all of these. Okay, wait for it. This is not virtual image. Okay, so this is going to through the focus and another ray. If you draw here, okay, so it will meet here in infinity, and if we produce backward, then the image will form in this part. Okay, and this image will be virtual in nature. Okay, so just you have to draw this ray diagram, and you have to mention here that if we place the object in between pole and focus, then in that case concave mirror can form virtual image of any object. Okay, so I think it will be helpful for you. Now let us move to another part of the same question, question number 5. The distance of object from a concave mirror is 2 times of its focal length. Then what will be the magnification of image formed by the mirror? Find it. Okay, so it is given that if f is the focal length, let us suppose f is the focal length, u is the object distance, b is the image distance. Yeah, and it is given that okay, sorry, mirror 2 times of its focal length, object distance is 2 times of focal length, this is 2f. Okay, object distance is 2f, so we can easily say that the magnification must be equal to 1, because this, in this particular condition, if object is placed at 2f, that is center of curvature of mirror, then image will form in this same region, same point. That's why the magnification will be 1. But here we are not given to write the logical answer, so we have to show it by the calculation. First you have to use here the relation mirror formula. Okay, 1 by f, this is 1 by 2f. We have to find out here first b. Okay, so on solving these all, 1 by f minus 1 by 2f, 1 by v, LCM will be 2f, this will be 2 minus 1 is 1, 1 by v, so value of v is 2f, and you have to apply the relation b by u, and 2f divided by 2f, that means 1. So logically as well as by calculation, the value is correct. Okay, now let us see another question, question number 6. Oh, sorry, not 6, this is our part of the question number 5. In this part we can see here it is also related with the light, and this is related with prism. What is the prism and angle of deviation of prism? Explain with necessary diagram. Just you have to write, draw a diagram. This is angle of prism, a prism having at least 2 refracting surfaces, which might be in different shapes, might be in triangular, might be in parallelogram form, or square, rectangle, whatever. Okay, so you have to mention that. And angle of deviation, for angle of deviation you have to draw this figure. Okay, so this is angle of deviation, this determine the angle in between the original or undeviated path of the ray and the deviated or emergent ray, the angle between the undeviated ray and the emergent ray of uh, of any prism is known as angle of deviation. You can mention in this way or another way. If you like to write in another way, you can say that the angle in between the undeviated and deviated path of ray when ray of light passes through a prism is known as angle of deviation. So after writing this much, I think it will be enough for this particular question. Now let us move to the second part of this question and see what is given here. A boy has tried to find the relation between the angle of deviation of a prism having angle of refraction less than 10 degree. He found that the angle of deviation for such a prism is independent of angle of incidence and angle of emergence. If the result obtained by him is correct, explain your answer by proper calculation. Okay, so you have to focus in this line. The angle is less than 10 degree. If the angle of prism is less than 10 degree, in that case we have to solve for small angle prism. Okay, small angle prism. Okay, and after solving this you will get a expression del equal to mu minus 1. You have to show this expression. Okay, I think you can do it easily. It is provided in your book. Okay, so from this expression we can see that angle of deviation is uh, proportional with angle of prism as well as the medium nature of medium of refractive index. That's why in this statement he found that the angle of deviation for such prism is independent of angle of incidence and angle of prism of angle of emergence is correct, because here from this expression you can easily say that angle of deviation is independent of angle of incidence and angle of emergence. That means the conclusion made by the boy is correct. Okay, so if you draw a prism and solve that uh, prism equation, and if you get the relation a mu minus 1, that will be enough, and you have to write just a footnote or conclusion that from this expression we can easily say that the angle of deviation is independent of angle of emergence as well as angle of incidence. That's why the conclusion made by the student is correct. Okay, so this is enough for this question. Okay, let us move to the another question. Now in this question, if you see here, it is related with electrostatics. Now let us discuss this equation 6. Okay, here it is given that state the Coulomb's law of electrostatic force. What are the factors affecting the electrostatic force acting between two charges? Okay, so you have to just mention the statement that is q1 and q2. That means the force acting between any two charges is directly proportional with their product of their magnitude and inversely proportional with the square. You do not have to mention, you do not have to mention in word, in equation. Just you have to write the statement, and by combining these all you can easily write the expression directly. Okay, and from here you can discuss the factors. That means f is inversely proportional. You do not have to write inversely directly, just you have to mention here f depends upon parameters. That means distance, charge, magnitude of charge, and nature of medium. Just you have to mention here, and that will be enough for this question 6a. Okay, now let's move to the question 6b, and here it is given here the let me read first. Okay, so what is Gauss theorem? How can you find the electric field due to charged spherical conductor having radii? So Gauss theorem actually gives tools to find out the net flux, electric lines of flux passing through any closed surface enclosing a particular amount of charge. So you can write here, you do not have to mention in detail, just write the statement and then after write this equation Q by epsilon naught, which means that net flux passing through any surface enclosing a particular amount of charge is 1 by epsilon naught times total charge enclosed by that surface. Now, in the next part of this question, it is given to find out the charge, sorry, electric field due to conductor in two cases. Okay, so just it is given here that radius, okay, radius of this sphere is a, and in first case b is greater than a, that means outside. The point where we have to find the electric field is outside this sphere, so you have to draw here imaginary sphere, then after this is electric field. Okay, and just you have to write if Fi is the net flux, then Q by epsilon naught. Q is the amount of charge over this surface, and then after you have to write another expression for flux which is equal to EA, and then after equating these two equations, EA equal to Q by epsilon naught, and this is the area of sphere, this imaginary sphere. So after writing the area, that is 4 pi epsilon, sorry, not epsilon, this is already here, 4 pi and then b square. Okay, 4 pi capital B, not capital B, b square, and then epsilon naught, and after rearranging this we'll get the required expression. And in next case is very interesting, because in this case you do not have to find out all of this, because in this case biologically you can see here the point lies inside where we have to find the electric field inside the sphere, because a is the radius and b is less than a. So this is our reason, uh, imaginary sphere surrounding this charge. But as we know that charge reside on the surface, outer surface of the conductor, any closed conductor, that's why total charge inside the sphere is zero, which means electric field is also zero. So that much will be enough for this question, which is question number 6. Now let us move to the question 7. Okay, and 7a, it is given what is the capacitance of a capacitor. Of course, capacitance is the property of capacitor by virtue of which it can accumulate or store charge over it, in which combination of capacitor the equivalent capacitance increases. So capacitance, if we add the capacitance in parallel combination, then result will be C1 plus C2 plus and C3. Okay, this is C1 C2, which means that if we add capacitor in parallel combination, or if you arrange the capacitor in parallel combination, then the capacitance of equivalent capacitance will increases. Okay, so that will be enough, and here it is given to draw the circuit. So just make parallel combination of 2 or 3 capacitor. Okay, and write this statement, you will get the enough score for this. Okay, now let us move to the question number 7b. If the capacitance of each capacitor is 100 coulomb, sorry, not coulomb, 100 microfarad, then find the equivalent for capacitance for this circuit. Okay, so we have to just break this circuit in simple form, though it is given in simple form. So I'm drawing it in slightly different way. Okay, so here is capacitor and 2 capacitors are here. Yeah, okay, C1, this is C2, this is C3, this is this is C5, this is C7, this is C4, and this is C6. Okay, point A and B. So we have to solve from this side. Okay, so if you see here, C3, C5 and C7 are in series combination because they are connected one after another. So if you solve for these three, you'll get one capacitor. Let us write this to be C dash, and for this you have to use the relation 1 by C dash equal to 1 by C3. Okay, 1 by C5, sorry, 1 by C7. Okay, so after solving that, you will have to see this circuit in this form. Okay, here, oh, sorry, for these three, we have supposed the equivalent capacitance for this three capacitor is C dash. Now, if you see here, this C dash and these two, that are C4 and C6 are in parallel combination. That's why if we suppose another capacitance, that means C double dash for these three, you will find it easily by adding C dash, C4 and C6. Okay, so on further solving this, we'll get here single capacitor which has the capacitance C double dash. This is C2 and this is C1. Okay, now if you see here, C2 and C double dash is again in series combination. Okay, so we can write here C triple dash for the equivalent capacitance for these two, and we can use here C triple dash equal to 1 by C2 plus 1 by C double dash, and finally we have to imagine it as, I have to imagine here C1 as this, and for these two we have to suppose here C triple dash. Okay, and finally if you see here, C1 and C triple dash is in parallel combination, so their equivalent capacitance will be, if you suppose that to be C, then C1 plus C triple dash. Okay, so if you solve in this way, then you will get your answer easily. Okay, okay, now let us see the last question of this group B, question number 8. Okay, and after that I will just do further solution of some MCQ in another video. Let me see first this. Okay, so 8a, discuss the cause of electrical resistance of a conductor. So electrical resistance, the cause of electrical resistance is continuous striking or collision of electron with the residue lattice or lattice point, or you can write here atom, somehow you can write that. Okay, so that will be enough for this answer, this question, sorry. Now let us move to the question 8b. In an experiment, a student has found that if the length of wire is made double, then its resistivity also get double. Okay, discuss whether the result is right or wrong with your proper explanation. Just you have to know that resistivity is just a property of material. Okay, property of material. It is independent of length. It does not depend upon length, area, or anything else. So the statement or the experiment performed by the student is incorrect or wrong, because you have to mention here resistivity is independent of length. By increasing or decreasing the length, the resistivity remains constant for a given material. That's why the experiment performed by the student is incorrect. Okay, that will be the enough for this answer, this question. Now let us move another question, and this question is 8c. If the radius of conducting wire is made 2 times and its length is made half of original length, then by how much factor the resistance of the conductor increases or changes, or let us calculate first. Resistance for, suppose first wire is rho L1, this is A1, resistivity remains constant, that's why I have written here rho as it is. And in the second case R2, now R2 rho, and length supposed to be L2 and this A2. Okay, now see the question once again. Radius of conducting wire is made 2 times. Wow. So we have to further express this as L1 and pi, and sorry, this is R1 square. You can write here. Pi is also constant. This is a cross-sectional area for the wire, and for this we can write L2 by pi R2 square. Radius is made 2 times. Yeah, radius is made 2 times and length is made half. So L2, sorry, L2 is half of L1 and R2 is twice of R1. So you have to use these all in the second expression. So R2 is equal to rho, let it be constant. So we have to replace L2 by L1 by 2 and this one R2 by 2R1 whole square. Now let's solve this row. Okay, here you will get 4 and this will be 2. It will multiply here. So you can write here 8. Okay, and L1, this is L1. Let me write this pi here, R1 square. If you see this is exactly as expression as this one, including rho. So you can write here R2 1 by 8, and then after for this all, okay, for this all you can write here R1. That means we'll get the answer. And in conclusion, you can write, if we increase the radius by 2 times and length by decrease by half, then the resistance of wire will reduced by 1/8 part of original value. Okay, thank you. This is the solution for group B. Okay, so and in group C you can see more questions here. Okay, you can copy this question and try to solve group C. If you have any kind of confusion regarding this group C, so please put your comment in our comment box. We'll try to solve and explain this in detail. Okay, you can copy this. Okay, so thank you for listening, joining us, and be connected. Our channel, we think, be very helpful for you, all of you, to tackle the different question. Okay, after completing 11, just be connected with us and see the solutions we have already made for 12 classes. That will be very much uh, helpful for your study. Okay, and be connected and subscribe our channel. Okay, thank you.